we'll just recollect what we have been doing all these days. Okay, then we'll do some little bit of problems. Yes. So just have a revision of what we have learned all these days. Maybe the normal probability curve alone, we'll just discuss the problems, how it came, etc. Okay, just quickly go through what is what. Okay, so in order to measure the accurately any population, the huge population if you have, it is not possible to measure the huge population, right? So what we do is, huge population, what we do is we pick out a small sample and we try to study this sample. From the sample we try to infer for the population. Okay, so this technique of estimating the measures of population, measures of population is nothing but what is measures of population? Measures of population is, which is called as parameter, right? So estimating this measures of parameter population, which is called as parameters, from the known values of, you will know the values of, from the known values of the measures of the sample. Okay, measures of the sample are nothing but it is statistics. See, I'm just revising for you measures of statistics. Again, it is called as statistics. When you measure for the sample, it is statistics. Okay, when you measure for the population, it is parameter. So this is known as inferential statistics. That is what we are trying to understand. We are dealing with the inferential statistics. So inferential statistics means estimating, the technique of estimating the measures of population from the known values of the sample are called as inferential statistics. So in order to make use of the inferential statistics, or in order to make use of statistical, otherwise it is called as statistical inference. Statistical inference, what we do? Statistical inference, we make use of the principles of probability. Principles of probability. From there only we have been talking about tossing the coin. We discussed all this. Tossing the coin once, tossing the coin twice, and how we get the probability curve. Okay, so we make use of the principles of probability, and what else? The properties of normal, probability curve, and the applications. Why we are doing all this? Till yesterday I have been talking to you about the region of rejection, region of acceptance in the normal probability curve. So I just want to have I want to give you a glimpse of what we have been dealing all these days. Okay, so from here, from the normal probability curve properties only, you are going to do some statistical inference. Okay, and we have already discussed about a person who is called as James Bernoulli, right? Hope you remember James Bernoulli. He was doing an experiment, and he understood that he can, with the tossing of the coin. Okay, with the tossing of the coin, he came to a great conclusion that tossing of a coin for n greater than n, or n is equal to 5,000, or n is a very great number, very large number. If n becomes a very large number, what happens? We are getting this tossing of a coin we get this follows a binomial distribution. Okay, it has got a binomial distribution, which is expressed as p plus q the whole power n times p plus q, where p denotes the probability of getting ahead. If you take a tossing of a coin, p is nothing but probability of getting a head,
Head.
and q is nothing but probability of getting a tail. Okay, so Bernoulli was able to find out if the number of times you toss the coin and the n is very large, he was able to get a binomial distribution. He was able to get a binomial distribution, which he decided to write it as p plus q the whole power n, p plus q the whole power n, which is expanded according to the Bernoulli as p power n. All this I told you, even though it's not necessary for you, we should know where it comes from. Q power, what do you have? Q power 1, then plus etc. etc. You have plus q power n. This is the expression you get. This is called as binomial expression, where p is the probability of getting a head. P is nothing but probability of getting a head, right? Already we have written it there. And q is probability of not getting a head or probability of getting a tail, I told you. Okay, so this is the binomial expression he was able to obtain, and the curve obtained from this binomial expression is called as the normal probability curve. Okay, that is how the normal probability curve we start talk about, discuss. How do we get the frequency curve? The frequency curve we obtain from the binomial distribution is called as normal probability curve. Okay, so this is called as normal probability curve, or otherwise it is called as normal curve. You can also call it as normal curve. Okay, this is just a revision we are doing. Normal curve. Okay, so what we are trying to say is it has got its, this normal probability curve has got its own properties. Next is we discussed about the properties of normal probability curve. What are the properties? It is a bell shaped curve. Okay, it is a bell shaped curve.
Asymptotic.
And the tails, what happens? The tails of the curve are asymptotic to the tails are asymptotic to the baseline, right? To the baseline. Okay, the mean and the median, the mean, median and the mode, median and the mode coincide. You got it? We are just revising. Okay, the fourth one is it has bilateral symmetry. What is bilateral symmetry? That means the area below the mean is equal to the area above the mean. So the curve will be like this. You have a curve, binomial curve. We learned all this. It is bilateral symmetry. No? The area on this side is same as the area on the other side. Here you have mean is equal to Median is equal to mode. Okay, got my point. Next is, what we do is, for all practical purposes, we divide this area into 6 sigma units. That you have to remember. The 6 sigma units, how it is distributed? Minus 3 sigma to plus 3 sigma. All this is clear for you. You have here minus 1 sigma, minus 2 sigma, minus 3 sigma, minus 3 sigma. Here you have 1 sigma, 2 sigma and 3 sigma. Got it? So it's very clear now. And the curve is unimodal. The sixth property is curve is unimodal. You have only one mode. Mode where it will occur, it is the maximum ordinate, you say. So the curve is unimodal. Okay, unimodal. And I also told you that the maximum ordinate of the curve occurs at the mean. The highest ordinate will be here. This is the ordinate. The highest ordinate will be here, where z is equal to 0. Mean, median and mode coincide and z is equal to 0. The highest ordinate, the distance is the highest ordinate distance. Okay, ordinate is nothing but it is equivalent to 0.3989, and the heights of the ordinate 1 sigma, 2 sigma and 3 sigma will be respectively what? 1 sigma, 2 sigma and 3 sigma heights. The ordinates will be, the distance is calculated. Okay, it is 2.42, 0.0540, and what do you have? It is 0.05, no, it is 0.44.
4.
Okay, 44. Okay, then this is important. All these are important. The area under the curve, the whole area, okay, the whole area under the curve represents the total frequency. So the total frequency is what? Using this, we have been doing the problem. The total frequency, frequency is nothing but it is denoted by n of the distribution. The area under the whole, the total frequency. I told you, tossing a coin only, you get a normal probability curve. So the total frequency is denoted by n. Okay, and then I told you the ninth property is that the curve changes its position from where, what? Convex
to concave.
concave. Okay, at where? At 1 sigma. 1 sigma, the position of the curve changes. It is more or less approximate here. Okay, so it changes its position. And also, what we have been learning, the next is important. So we will have the next page and we will talk what all we did. And also, what happens? Skewness is equal to 0. Okay, what are the other properties? Skewness is equal to
Kurtosis.
0, and kurtosis is equal to what? Kurtosis is equal to
0.253.
0.263. Okay, so the other things, if you want, you learn, otherwise you can just leave it. So next one is, I think I mentioned this, or I do not know whether I mentioned unit normal curve. Okay, what is unit normal curve? The table which you have it, we have been going through the table is here. Let me show you the table. The other day you downloaded the table, no, normal probability table. So the table areas, this is important that you have to learn. The table of areas of normal curve, okay, table of areas of normal curve is prepared for which values? For n is equal to 1 and sigma is equal to 1. Okay, table of values, we are seeing n is equal to 1 and sigma is equal to 1. That is why it is called as unit normal curve. Is it clear? So whenever you have this normal probability curve, since the table of areas is prepared for n is equal to 1 and sigma is equal to 1, so any values different from n and sigma, n is equal to 1 and sigma is equal to 1, we you have to convert the scores into, for doing the problems, what we do is, we convert the raw scores into sigma scores. You got me? So that is why you had the formula z is equal to x minus x bar divided by sigma. Any problem that is concerned with the normal probability distribution, when the values of n and sigma are different from n is equal to 1 and sigma is equal to 1, what we have to do, the scores should be converted into sigma scores. This is called as sigma scores. What is the other name? Are the standard scores. Did I tell you it is standard scores? Standard scores, or otherwise called as Z scores. People sometimes call it as Z scores. Okay. So any value different from n is equal to 1 and sigma is equal to 1, the scores should be converted into what? Scores should be converted into sigma scores. Any scores that should be converted into sigma scores. I hope the up to this was clear for you. So any problem concerned with, we will refer to the table. Always we'll refer to the table which is given values for n is equal to 1 and sigma is equal to 1. Right? And we have been going through the applications. What are the applications we have been going through? Determination of one. This will be continuing. So when we are continuing, I'll tell you what all we are going to do. Applications, we have been doing some little bit of problems there. Next is, we revised about, what was the next one we revised? It was about standard error.
Error.
So what is standard error, girls? What is standard error? Standard error is nothing but, what is standard error? What is the definitions? Before getting into standard error, I told you what is sampling error, right? Did we not discuss about sampling error? Sampling error is the difference between the actual population parameter and the estimated population measures obtained from the statistics, sample statistics, right? So it is the difference between the what? Actual population parameter, difference between the actual population parameter and the estimated is nothing but, what is estimated population parameter is nothing but your sample statistics. Okay, girls, 1 minute. I have some little bit of disturbance here. Just a minute.
Amen.
Okay. Okay, I am back. Okay, so from here we have been discussing about how we got the standard error. Already we know that, what do we have? Already we know that the normal probability curve. So normal probability curve, we are getting it from tossing a head or a tail, etc., etc. Here it is a different story. for defining the standard error. We take sample means. Okay, I told you you can take sample means M1, M2, M3, etc., M4, etc. All these, what happens? You take and find a distribution of these sample means. This sample for normal probability curve, you are taking the coins, right? Tossing of coins. Whereas for this standard error, we are taking the sample means. So, etc. You take number of sample, okay, large number of sample means. This will again form a normal distribution curve. That is what we studied. And if it forms the normal distribution curve, it has to follow the properties of the normal distribution. And the normal distribution, we have been revising about the properties. So again, this has to be divided into sigma units. So here, instead of having sigma units, you cannot have sigma units, because here you have 1 sigma, 2 sigma, 3 sigma, etc. Here mean, median, mode and all will coincide. Median and mode and all will coincide. Here you have 1 sigma, you have minus 2 sigma, etc. The same value you cannot have, because it is the sample means. Okay, it is different. It can satisfy the properties, but it is sample means. So what do you have? You have different properties. So here the standard deviation becomes what? The standard deviation of the particular sample distribution. This the sample means together form the sampling distribution, otherwise called as sample distribution. Okay, this will form a sample distribution. It is otherwise called as sampling distribution also. And the standard deviation of this particular sample distribution is called as the standard deviation of this particular sample distribution is called as the standard error. And I told you the standard error is defined to be what? Sigma divided by root n. Okay, this is the formula which you have to keep in mind. And sigma divided by root n whenever n is greater than 30. And this the same standard error is sigma divided by root n minus 1 whenever n is less than 30. I hope up to this we revised. We saw in the class. That is clear for you, I think so. The next concept was, let me write the standard error formula here. You have standard error. You have the standard error. Okay. You will have standard error equal to, it is denoted by standard error. You have standard error of the mean is equal to, it is denoted by sigma m, which is equal to sigma divided by root n. This root n is whenever n is greater than 30. Similarly, you have standard error of the mean, which is denoted by sigma m, which is equal to sigma divided by root n minus 1 when n is less than 30. All these are formulas. It is used for doing the problems. Girls, you are finding out for the standard error of mean. One question for you. Will you have standard error of median? Will you have standard error of mode? All these are standard error of mean, of mode. You will have all this because the normal probability, the measures of central tendency, any distribution can be calculated making use of the what? Mean, median and mode. Yesterday you had your seminar also. Okay. Whenever here mean, median, mode and coincide, mean, median and MD. I'll write it as MD and mode ME. Okay. All this coincide. You can find out the value of standard error of the mean. You can also find out the standard error of the median. You also have the standard error of the mode. And you can also calculate the standard error of the standard deviation. Standard error of the standard deviation. It goes little bit complex. Why I am repeating is the other formulas are also there that you have to keep in mind. That's why I am saying. Okay, so you can find out. They have found out standard error of the median. It is represented like this: sigma mdn. It is nothing but sigma dn. They have calculated it to be 1.253 sigma divided by root 10. 53 divided by sigma root 10. Okay, or it is also 1.858. They have given it in terms of quartile divided by root 10. I think you needn't have to much worry about all these formulas, but you should know there is standard error of the median, there is standard error of the mode, there is standard error of the standard deviation, there is standard error of the quartile deviation, there is standard error of the percentage if you are calculating, there is standard error of the correlation. Okay, R represents correlation. So, and this standard error is not an error. Our next discussion is this standard error is not an error. Why the standard error is not an error? Can anyone say the answer for this? I make this as homework because I am repeating a few things because I am introducing some important concepts. Okay, like why standard error is not an error, why we have standard error of the median, how you are able to get standard error of the standard error of the mode, standard error of standard deviation, standard error of correlation. You have all this, no? Standard error of percentage, standard error of quartile deviation, everything you have. So why standard error is not an error? That is a question for you, which you will find out for me. This is an homework for you. Maybe tomorrow we'll discuss. Before that, you just find out. Let me know who's thinking and whether you have followed the concepts. Okay, next is I told you, since this distribution curve, that is we have the sample means forms the sampling distribution or sample distribution, and it follows what curve? Normal probability curve. It also satisfies the properties of normal probability curve. So, and this will have what? I told you the standard deviation of this sampling distribution is standard error. Okay, and this standard error formula is sigma divided by root n. You can calculate this by sigma divided by root n. So if this is sigma divided by root n, and if it is following the normal probability distribution, how will be the limits? Okay, properties. So the sample distribution is normal according to the property of the normal curve, and between the limits mu minus sigma divided by root n and mu plus sigma divided by root n, what happens? You have 68.26% of the total sample means will fall. Sample means, because we are having only sample means here. Sample means will fall. Okay, and between the limits, all this we have learned already. For the normal probability curve, we have taken it to be 1 plus or minus sigma, 2 plus or minus sigma, 6 sigma units we have said. Okay, it's not like that, not 1 plus or minus sigma. For the normal probability curve, we have divided it into 6 sigma units. 3 sigma, from minus 3 sigma to plus 3 sigma. So the limits will be minus 1 sigma to plus 1 sigma, minus 2 sigma to minus 2 plus 2 sigma, minus 3 sigma to plus 3 sigma. How it will be? you have minus 1 sigma to plus 1 sigma, right? So this will be. So here, since it is the sample means, here it is only the frequencies. Since it is the sample mean, what happens is sample means you have the population mean. Here it will be mu. Okay. The other things I told you, these are means M1, M2, M3 you can take. And instead of having 1 sigma, you have sigma divided by root n. You have sigma divided by root n, 2 sigma divided by root n. The deviations will be like this, minus sigma divided by root n. And this is the, since this is the sample means of the distribution, it becomes the population mean. So this here you will have mu, whereas for the normal probability curve, you will have mean to be equal to 0, median is equal to 0, etc. Here you have to represent this limits by, that is here 68.26 percentage. It is nothing but 34.13 or something like that, right? So the whole of the area you say it is 68.26. So the limits are mu minus 1 sigma, mu minus sigma divided by root n plus mu plus sigma root n, where 68.26 percentage of the total sample means will fall. Similarly, I told you 2 more values you have to remember in mind. What is it? Mu minus 1.96 sigma 1.96. Okay, these are standard values which you have to remember. I told you sigma divided by root n, comma mu plus 1.96 sigma divided by root n. How many percentage of cases lies in these limits? 95 percentage of cases lies in this limit. Similarly, I told you, you have to keep in mind the one more value, mu minus 2.58 sigma divided by root n, mu plus 2.58 sigma divided by root n. In this, 99 percentage of cases lies. Okay, in this curve, 99 percentage of cases lies. Sample means will fall. So what happens is the probability of falling between the limits, mu plus or minus sigma divided by root n is this. I have already told you this, you call it as the probability value. Girls, this is the probability value. So the probability of the sample means falling between the limits mu plus or minus sigma divided by root n is 68.26, and otherwise it is called as 0.6826. Okay, because for the normal probability distribution, you have calculated the cases to be n is equal to 1, sigma is equal to 1. Here it is sample means, so you can take n to be a larger number. So larger number, n can be 10,000 also. So you have 0.6826. Okay, and between the limits mu plus or minus 1.96 sigma divided by root n, it is 99. It is 95%. And between the limits mu plus or minus, that's what I am repeating it, 2.58 sigma divided by root n, what you have by root n, you have 99%. All these are important, that's why we are repeating it. It is 99%. So this mu plus or minus what is it? Mu plus or minus sigma divided by root n, mu plus or minus 1.96 sigma divided by root n, and mu plus or minus 2.58 sigma divided by root n are 68.26 and 95% and 99% confidence intervals of mu. We are introducing this confidence intervals. These plus or minus values are confidence intervals of what? Mu. Okay, since it is population, it has to be mu. Okay, the upper and the lower values of these confidence, upper and lower na, this is the upper limit, This is the upper limit and this is the upper limit. And this is the lower limit, lower limit, lower limit. The upper and the lower values are called as confidence limits. Okay. The intervals are confidence intervals. You call this as an interval, this as an interval, okay, this as an interval, okay. And these values are called as, these are your limits, okay, which are the upper and the lower values. You have the value, no? Here you have mu minus sigma divided by root n, mu plus sigma divided by root n. These are all values. So those values are called as confidence limits. Got it? Got it, girls? So from here, I'll use a different pen because I am using the same PowerPoint here. So from here, we say that 95% of the total sample means fall between the limits mu plus or minus 1.96 by sigma divided by root n. So that means only 5%, 95 la remaining another 5%, yeah, only 5% what happens? Fall outside the limits. The 95 எங்க இருந்து வரும், எங்க இருக்கும், இந்த 5% வந்து இங்க இருக்கும், 5%. அந்த 5%ல இந்த சைடுல 2.5, இந்த சைடு 2.5 அப்படி வந்துரும். Okay. Next is similarly 99% of the total sample means falls between normal curve ஞாபகம் வச்சுக்கணும். Okay. 99% எங்க fall ஆகுது? mu minus 2.58 ல வருது. So the remaining 1% fall outside. 1% இங்க இருக்கும். அந்த 1% எப்படி கொண்டு வந்துரும்? இங்க 0.5, இங்க 0.5 னு போயிடும். சரியா? Remaining 1% falls outside. I hope it is clear for you. Hence these values, which values? Mu plus or minus 1.96 sigma divided by root n and mu plus or minus 2.58 sigma divided by root n are known as what? 0.05 and 0.01 level of significance. Got me? Level of significance. Okay, and the values 1.96 and 2.58 are called as what? Critical values. Yesterday itself I completed this. Again I am saying critical values. I hope up to this is clear for you. Yes, and 0.05, 0.01 are called as the 0.05 level of significance. This is level of significance, and 0.01 level of significance. And if the cases, this region is called as the area of acceptance. In the region, area of acceptance regions, the region falling outside this is called the region of rejection. So this is the உள்ள இருக்க இந்த region வந்து area of acceptance, and the area outside is the region of rejection. So if the p-value falls within this region, you accept the hypothesis. If the p-value falls outside this region, you say that the hypothesis, testing of hypothesis is rejected. The hypothesis which you have framed is rejected. I hope up to this is clear for you. This is only a repetition, I made it. Girls?
Yes, ma'am, it's clear, ma'am.
Yes.